Welcome to queenon7.com. Today we're going to look at the electrolysis of aluminium oxide. Oxides of the metals are known as the ores of those metals, and in the earth crust we rarely find these metals in the pure form except platinum, copper or other unreactive metals like gold, which are less reactive and you can find them in the pure form. But when we talk about the other in the reactivity series, most of those metals are actually found in the form of their compounds like oxide, sulfate and chlorides. Anything which is actually oxide, mostly we found aluminium as a form of aluminium oxide, that they are known as ores of aluminium. Now aluminium metal has got a huge amount of uses in the industry, but when you want to separate it, you will actually find them in the form of the dark red mud. And that mud is actually aluminium oxide. Because it's aluminium oxide, commercially, the name of that ore is bauxite. And the bauxite has a melting point around 2000 degrees centigrade. Roughly, it's 2070 degrees centigrade, but almost 2000 degrees centigrade temperature. So that means if you are going to dissolve aluminium oxide like other ionic compounds in water, it's not going to dissolve itself. So what we're going to do is, if we do electrolysis, our main purpose, you need to remember, electrolysis means you actually break the metal from its compound. So if this is the formula of aluminium oxide, you need to break aluminium from the oxygen. Aluminium, as I said, the first part is always positive, so you do not need to worry that which one is actually going to be the positive ion. So aluminium is the first part, so it will carry +3 charge because it belongs to the third group, and it has 3 electrons in the outer shell, and to make it 8, it has to gain 5, which is a hard job, so it will lose all 3 electrons. So aluminium will actually lose all 3 electrons to make aluminium ion, which is then connected with the oxygen to make aluminium oxide. So that's how it actually converted into aluminium 3+ ion. So aluminium is 3+ ion. Oxygen belongs to the 6th group. It has 6 electrons, means it requires 2 more. It's an easy job to gain 2 electrons. So anything which gains electron, it actually gets negative charge. Because it is going to gain 2 electrons, it will be 2 negative ion. Now you're going to split it into 2 ions, and these 2 ions cannot be separated by just dissolving in water. You have to spend so much money, and it's going to increase the cost to extract aluminium from its ore bauxite. So you have to reduce the melting point with any chemical reaction, so we can actually reduce the cost. Another compound called cryolite. Cryolite is another compound, a chemical which is used to add into the bauxite. Once you add it into the bauxite, which is aluminium oxide, the temperature will go down to 960 to 1000 degrees centigrade. So you are saving a lot of money if you want to start the electrolysis, but before you actually start the electrolysis, you reduce the melting point up to 1000, which is a half of the amount of the melting point of the aluminium oxide. Now let's have a look. There are so many different sort of what do you call it as examples you have for these electrolysis, and you have different shapes as well. I'm just going to draw a general one. I'm not going to draw one which is actually difficult. So for example, if you have electrode there, I will show you in the question mark. So if this one, it doesn't look like that, to be very honest. You have so many of those electrodes in there. You probably have so many of the anodes in there, so you probably have 3 anodes there, which has a reason, and I will explain that. Why do you have 3 anodes there? And you have a cathode there as well. You have a steel plate there, which we use. That's the outlet. So you have put aluminium oxide, Al2O3, and you have put cryolite, and that is going to reduce the melting point. Once you're going to melt it, you will be producing Al3 plus and O2 negative ion. We are not making an aqueous solution, we are just melting it. Because you have only melted, so it's a molten form. We are using a molten form to do the electrolysis. You can do the electrolysis two ways. Either you have an aqueous solution or you can have the molten form. The moment you're going to actually have aluminium and oxygen ions started moving after melting them, obviously the O2 negative ion will go to the anode because they are opposite charges. Aluminium will go to the negative electrode, which is actually 3 plus ion. After that, you can see the half equation. So, half equation means what will happen to each ion on each electrode. If aluminium goes on to the cathode, aluminium is actually in the 3 plus ionic form, and it has a lack of electron. This positive sign means it has a lack of electrons, so it has to gain those electrons to make a pure aluminium atom, which is actually a metal. The moment it is gonna gain 3 electrons, it will make aluminium solid. This one is liquid and this one is solid. Sorry, it is still gonna be liquid. And this liquid aluminium from here, once it's gonna gain that, from here it's gonna start as an aluminium liquid metal, will drain out. So the at cathode, aluminium gains 3 electrons, which is called reduction. In chemistry, anything which gains electron is called reduction. On the anode, at anode, which is a positive terminal, you have O2 negative ion, which is going towards it. Negative means it has an extra electron. So O2 negative means it is carrying extra 2 electrons, which doesn't belong to oxygen. So oxygen has to calm down, and oxygen has to lose those electrons. Something which lose electron will be written on the other side. Oxygen will be converted into O plus 2 electrons there. Now, oxygen, hydrogen, fluorine, chlorine, bromine, they cannot stay in the form of just O. So 2 oxygen ion will actually go there and they will combine together into O2 form. So each oxygen ion will actually lose 2 electrons. If I put 2 oxygen ion, all together they will lose 4 electrons, and it will be actually a gas which is produced in the solution. Now, once you have produced oxygen gas, the oxygen gas will go there, which is made by carbon. All these electrodes, both of them, you can Google that, the electrolysis of aluminium. You will see a very different shape where you have a steel bucket and you have those electrodes around it. The cathode is actually laid here, and then you have anode on the top, and you will see a total different shape. But I'm just trying to explain it as in a simple form so you can understand it. The oxygen is actually very reactive. It's going to go to the carbon, and here it is going to react with the carbon electrode itself. Once it's gonna actually go to it's not gonna go to the cathode, it is going to the anode. So oxygen is going to combine with the carbon and produce carbon dioxide. So one product is aluminium metal at cathode, but at anode you have 2 products. One, oxygen gas itself, and you will also get oxygen combining with carbon to produce carbon dioxide. So you will have actually 2 gases produced at the anode. So that's an extra product. So you can say, if they ask you 1 mark question, what is the extra product? So you can say extra product will be a carbon dioxide. There is no involvement of water, so we do not have H positive ion or OH negative ion. I'm going to upload another video about the electrolysis of brine, which is sodium chloride, and which will help you to understand how we can actually control those 4 ions, 2 positive and 2 negative. Thank you very much.